Hey there! Today we're going to talk about addition and subtraction equations and how to solve those. We'll start with a couple just vocabulary terms. An equation is basically a math statement that says two expressions are equal to each other. So if we look at this one, this is telling us that x plus 12, that quantity, is equal to 19. And when we're talking about equations and we're talking about solving them, we want to always keep our equations balanced, which means we always want each side to be equal to the other. And a great way to remind students about that is to use a balance or a scale and show that on one side we have x plus 12 and on the other side we have 19, and x has to be a solution that makes that statement true, that makes them equal to each other and balanced. So the solution then is the value for the variable that makes the equation true. And so once we solve this, we would see that x is equal to 7 because 7 plus 12 is equal to 19. And if we solve this side, 7 plus 12, we get 19, and that is equal to the other side, which is 19. Now, students could look at this and potentially test other solutions. They could say, oh, I think it might be 6. And then test the solution to see if it makes the statement true. 6 plus 12 on this side, 19 on this side. 6 plus 12 is 18. That is equal to 19? No, it is not. So 6 is not a solution for that equation. As we solve these equations, addition, subtraction, and then moving on to multiplication and division, we will use the inverse operations to solve. So addition and subtraction are inverse of each other. They are opposite of each other, and we kind of say that they undo each other. So in this particular equation, adding 8 would be undone by subtracting 8. So we tend to we have to use those inverse operations to solve. So if we're going to go ahead and solve this equation. Now, some students will look at this and say x plus 8 equals 20. Well, I know x is 12. So the answer is x equals 12. And that's great that they know that. But they need to be encouraged to write out the work that proves that at this point, because as the equations get more and more complex, if they don't have that foundation of writing out their work for each step that they do, their work tends to kind of fall into confusion and it's very hard to follow, and sometimes they then get lost. So first we want to identify what operation did we do in here. In this equation, the operation that was performed was addition. Something was added to, 8 was added to something, which is x, to get 20. So to undo that, or to solve for x, we would take that 8 away. We would undo that. And because we do it on the left side, we also have to do it on the right side. If we added on 8 to get to 20, well, then we have to take away the 8 to figure out what we started with. Now, a positive 8 and a negative 8, or 8 minus 8, ends up being 0. So that drops out of the equation, and we are left with x. And 20 minus 8 is 12. And so we find that x is equal to 12. But this step, this showing the work, is very important. And I have my students check their work as well. So these are simple checks, and they might say, why do I have to write this down? I know that 12 plus 8 is 20. But again, it's setting the foundation for when the equations become more and more complicated. And sometimes they do make a silly mistake, and then checking points that out. So 12 plus 8 is equal to 20, 20 equals 20. So I know that x is equal to 12 in this case. Another addition equation, t plus 16 is equal to 50. So we added 16 to t to get 50. So if we take that 16 away from both sides, and again, we added here, so we will subtract. That is the inverse. 16 minus 16 is nothing, so we are left with t over there. And 50 minus 16 is 34. And again, we would check it. We would say 34 plus 16 is equal to 50. And sometimes students will just be like, I'm just going to write 50 because I know it's supposed to equal to 50. But sometimes, they will go over here and they will write the work as they should to kind of prove it. 6 plus 4 is 10. Carry the 1, 3, 4, 5. Yep, I got 50. Or they can, check it on a calculator to verify if you are okay with that. Now, on these two equations, the operation that's happening in here is subtraction. So we had an x, we took 28 away from it and ended up with 19. So if we undo that, we would be adding 28 back in. So we add 28 to both sides. A negative 28 plus 28 is 0. So that becomes just x. You could write x plus 0, but there's not much point in writing the plus 0. When that drops out, we can write just the variable x. And then 19 plus 28, that's 47. And then sometimes it's a little bit more fun to check subtraction because you might actually have to do the subtraction problem. Students might actually have to go 47 minus 28. If they thought about compensation, they could say 48 minus 28 is 20. And then we took from one less than 48, so it would be 19. But if they want to go through the algorithm, 17 minus 8 is 9, and 3 minus 2 is 1. So x is equal to 47. In this case, we have 22 on the left side and we have the variable on the right side, and that's perfectly okay. We still were doing subtraction here, so the inverse of that is to add. So we had taken 16 away from x, and we're going to add the 16 back, kind of undo it. And so we add 16 to both sides. Negative 16 and positive 16 is nothing, and x is equal to 38. And then again, we do the check. 22 is equal to 38 minus 16. So the biggest thing I would emphasize here with students is that they do actually write out the work. I think it's very important for them to write out the work because when they move on to 7th grade math and 8th grade math, they're going to have multiple steps. They're going to have more than one step to do, and it just helps get them in that great habit of writing everything out. And when the numbers get bigger, it's not quite as easy to do something mentally as the x plus 8 equals 20 and just know that that's 12. All right, that is it for adding and subtracting equations.